So your learning journey, it's a 3 month training program, and I'll share the roadmap with you. Month first, you'll have the foundation and test strategy mastery. That is 1 to 4 weeks. You'll be doing this. In this, you'll cover SDLC, that is software development lifecycle, software testing lifecycle, SDLC, uh, QA mindset, learn Jira, test trail, black box testing techniques. It will include BVA, decision tables, and you will be writing professional test cases and test plans. At the end of this month, you'll also be completing a project that will include web application test cycle. Okay, and apart from this, you can ask as many questions as you can. And apart from that, if you have any personalized projects that you need special assistance, or you need to ask anything about it, you can also include that in that. Month 2 will include execution defect and specialized testing, that is week 5 to 8. And this will include master defect lifecycle, bug reporting, learn usability, compatibility, accessibility testing. You'll also learn database testing with SQL, and in tools you will also learn Postman for API testing. Okay. The project, your second project will be full stack testing challenge on a live project. Okay. After that, you will have more confidence on yourself. Month 3, that is week 9 to 12, you will be on real world readiness and career launchpad. That it in this you will cover understanding of agile dynamics, how agile teams works, learn test automation basics, professional resume and LinkedIn profile. So our team will assist you in building your professional resume, enhancing it, and also enhancing your LinkedIn profile. Master QA interview questions and salary negotiations. Okay. So day one learning objectives. Any questions till now in this roadmap? Okay, I assume that is clear to everyone. Day one learning objectives. So today, we lay a groundwork on software testing expertise. By the end of the session, you will be able to understand software types, that is explore the nature of software, its various classifications from system software to application software, product versus software. This includes difference between a software developed as a product for mass market or custom software tailored for specific projects. The next will be service versus product companies. Learn the core differences between business models and operational structures between service based and product based organizations. You'll also learn software development lifecycle, SDLC. In this, you'll grasp the structured approach to software development. This includes key phases like planning, design, implementation, and maintenance, that is followed in SDLC. Then software testing fundamentals, that is SDLC. In this, you will learn the essential introduction to principle, purpose, and importance of software testing, ensuring the quality of the SDLC process. Training, logistics, and setup. So it's very basic. To ensure a smooth and productive learning experience, you will require uh, the practical details for the software testing training are basically training duration, as you all know, is 3 months intensive program. Daily schedule and commitment, you all know, it's very flexible. We can also provide one-on-one coaching via Google Meet if anyone requires, and time commitment will be at least 10 to 8 to 10 hours per week, including the practice sessions. That includes all your Q&A sessions. Test Training format will be personalized one-on-one coaching and with hands-on project, and it will be an interactive learning with real-world applications. Required tools are also basic. It includes a modern web browser. Will also help you create your accounts on Jira, TestRail, Postman, and basic SQL setup. Okay, we'll provide all the details. Don't worry about it. Learning materials include all the presentation slides and project materials, and all these presentation slides and materials that we use will be accessible for you for the lifetime. And of course, questions and support, personalized one-to-one supports for throughout the program. So since the training is about software testing, uh, the first question that comes in mind is, what is a software? Anyone would like to answer this? A basic understanding of what is software. Anyone? So basically, software is a collection of instructions, statements, and logical operations that tell a computer system what tasks to perform and how to execute them. Means it's a simple collection of instructions. It's a simple collection of statements. Okay, that includes logical operations. And what do these logical operations do? They tell the computer system the task that it needs to perform. Okay, and it also executes those tasks. It serves as a bridge between users and hardware, enabling computers to solve problems and complete any complex operations. Okay, so think of software as a brain of a digital system. Okay, so since it basically processes all the information just like our human brain does. Okay, it makes decisions and delivers results based on the predefined logic and user inputs. Just like we give any input to our brain, like we see something from our eyes, we process it and we take a decision based on the what we process the information. Okay, similarly a software processes information, makes decisions, and then delivers result based on the predefined logic and user inputs. Now we come to the classification of software based on usage. So there are two types of softwares: product software and project softwares. The basic difference between project and product software are: product software are designed for a broad market segment, and project softwares are built for custom built specific client needs. Okay. Uh, uh, by the end of the next slide, you can there is a small task that you can just think of three software applications that you use daily and classify them. Okay, as product, is it a product software or a project software? Yeah, product versus project software. So a product software is a software developed for a segment of customers for a broad market audience. So what is product software? It is basically used for a broad market audience. Okay, it targets a specific segment of customers. It is not for a broader uh, this thing broader audience. The applications are designed to serve multiple users with similar need across different organizations. Okay, so it is built for mass market appeal, standardized features and functionality, regular updates and version releases, sold through licenses and subscriptions. And there are very simple examples that we use in our daily basis are operating systems, productivity suites, and antivirus softwares. Yeah. So yeah. So operating systems are basically product softwares that we use on our daily basis. Operating systems are target. They usually target specific. They are basically developed for a broader market audience. Everyone uses it. it does not refer to a specific client. Like anyone can purchase it and use it. What are project softwares? Project softwares are basically made for single client, okay, for unique and specific requirements, like banking systems, okay. They are customized based on the client specifications, okay, specific needs of the client. Project softwares fulfill basically the specific needs of those clients. They address unique business needs, one-time delivery and maintenance contracts. So the project software and product software differs in delivery also. Project softwares are usually delivered on one time, and then regular maintenance is done based on the various contracts. Yeah. uh, Examples of project softwares are banking systems, enterprise resource planning, and custom CRM platforms. So, only specific users can access these project softwares, not everyone, whereas product softwares everyone can access. In real world scenario, your company is deciding whether to build a custom inventory management system software or buy an existing solution like SAP product. What factors would influence this decision? Think about it. The cost, customization, needs, time to market, and maintenance. So you can just think about it, and later on in next class you can share your thoughts on this. So types of software companies. What are basically what type of what are software companies? There are two types of software companies: service based companies and product based companies. Okay, this is the basic classification. So software industry operates through two primary business models that I already said, and they both have different approaches for to software development and client engagement. So, what is service based companies? Service based companies are basically those companies that develop custom software solutions for individual clients. Okay, based on project project to project basis. So they do not target a specific project, but they target their clients specific needs project wise. Okay. And what is product based companies? Product based companies have their own product, organizations that create and maintain their own software products for broader market. Okay. This is the difference between service based versus product based. So companies that concentrate on developing and refining their own software products for the market, they invest heavily in research, innovation, and long term product evolution. Whereas service based companies are companies that provide customized software development services for individual clients. Okay, they handle diverse projects across industries and technologies. The key characteristics differences. So basically, product based companies focus on continuous product improvement. Okay, whereas client this thing service based companies focus on client specific project development. Product based companies are scalable, provide scalable solutions for mass markets, whereas diverse service based companies focus on diverse technology stacks and domains based on the individual clients. Okay. Product companies focus on innovation and innovation development cycles. It focuses more on innovation research, and revenue is through licenses and subscriptions, whereas service based companies focus more on contract based engagements, not on licenses and all. And the revenue is through billable hours and projects based on the clients. Okay, examples of product based companies are Microsoft, Amazon, Google, Facebook, Adobe, and Salesforce. So these organizations are product based, and we already used almost all the companies products, right? Whereas service based product companies are Accenture, Wipro, Infosys, TCS, Cognizant, Capgemini. How does these companies work? These companies have their clients, and their clients provide them their specific requirements for which they uh, work based on the billable hours, right? So there's a quick question: if you are starting your QA career, you need to think this: what kind of company would you prefer, and why? So while answering this, you should consider learning opportunities, work variety, job stability, and career growth within it. And this is a common question that is asked in QA interviews, like what kind of what is your goal in trying to get this job, and why do you want this job, as this is service based or what is product based. These kind of questions you get, right? SDLC. So software development life cycle. What is SDLC? SDLC is systematic and step-by-step process that software teams follow to plan, create, test, and deploy high-quality software. What is a high-quality software? A software that is exactly up to the mark, and it follows all the instructions that are provided with from the client, right? It provides a structural framework that ensures projects are completed efficiently while meeting all the requirements and quality standards. So first phase in SDLC is requirement gathering. So what is requirement gathering? Requirement gathering includes collecting and documenting what the software needs to do. Okay. Basically, requirement gathering, it can be done in from two ways based on what kind of a software is it. It can be done from the within the company. We can have a meeting in which we can discuss the project requirements, and clients can also provide us the requirements in service based companies, right? So collecting and documenting. So collection is done. Documentation of that requirement is also very very necessary. What is the reason why documentation is necessary? Anyone? Yes, yes. So to understand the requirement, documentation is necessary. Once the we understand the requirement, software will not be developed within a day, right? It will require some time. So just to avoid any conflicts between client, between the team, or to ensure that everyone in the team as well as the client is on the same pace, okay, we document everything. So requirement gathering also includes documentation, so that everyone is on the same page and everyone is doing whatever is required to do. Okay. If documentation is not done, so there can be a lot of confusion, like today some we understood something, and half of the people will forget in next month, like what did we do last month, okay, or what was asked, what did the client ask us to do. So that is the reason. Analysis. The next step is analysis. Analysis includes evaluating feasibility and defining project scope. Okay. So once we gather the requirement, we process it. Okay, and we see what is the feasibility, what is the scope of that project, and we define it. Okay, if there is any gap, we again go to the concerned person and uh, require the information that is not provided to us. Okay, or clear our confusions again to the first step, and then again analyze it. The next step is design. So design basically includes creating architecture and technical specifications. Okay, creating an architecture and technical specifications of that requirement. Okay, this includes all the designing of what the requirement we have got. The next step is actual coding. Okay, building of the actual software components that coders do and what the testers test. The next step is testing. So what does testing include? Testing includes verifying the functionality and the quality standards. So testing is done to verify the functionality and quality standards of the product that coders have coded, okay, based on the requirement. The next step is deployment. So deployment is once the testing is completed, okay, all phases of testing are completed and there are no bugs left, all the cycles have been completed, we deploy the product. Deploy is releasing the software to the production environment, okay. And then is release and maintenance. So release and maintenance includes supporting and updating the live application. There's one more practice question, that is, why do you think that testing happens in multiple phases of SDLC rather than just at the end? Okay, so any guesses, like what is the reason and what happens, why is it done at every phase or multiple phases? Anyone, just volunteer. Any guesses? So how will you achieve maximum client satisfaction? Mm-hmm. 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 Anyone else? Yeah, it saves time. 100% correct. Anyone else? Any addition to this? So yes, uh, why we do it in multiple phases is there are multiple points. Okay, like we need to do testing in multiple phases so that there are very few chances that we leave any errors. Okay, and the also another reason to test in multiple phases rather than just at the end is that it saves our time, okay, and the quality. Like if we wait till end to test, there can be multiple issues. If we keep on testing in multiple phases, we get issues in the starting only, and the issues that there can be multiple issues at the end that raise a lot of other issues. Issue raising issues can also be created at the end, okay. But if we test them earlier, we can fix them and it will avoid so many list of issues, okay. So understanding the software testing is it's a systematic process of evaluating a software application or product against clients requirements and quality standards. It's a critical phase that ensures software functions correctly, meets user expectations, and is free from critical defects before reaching the end users. There are two classifications basically, manual testing and automation testing. So, what does manual testing include? Testers manually execute the test cases, exploring the application from users' perspective to identify bugs and usability issues. Okay, whereas automation testing, Software tools script automatically and execute test cases, enabling rapid, repeatable testing for regression and performance scenarios. Okay, so the benefit in manual testing is that it identifies bugs and usability issues. Okay, whereas for the repeatable testing, like whatever test cases need to be executed repeatedly, automation testing helps us to do it very fast. Okay, regression and performance scenarios. So there is a important point here, like both testing types complement each other. Manual testing and automation testing both complement each other. Manual testing excels in exploratory and usability testing, while automation handles repetitive tasks and large scale regression testing efficiently. Okay, there's a real world scenario that you're testing a banking app money transfer feature. Okay, uh, the developer says that it's working fine on my machine. What would you do as a QA tester? Just think about it. Okay, there are different things that you need to consider. Like a QA always considers like testing on different devices, network conditions, edge cases, and user scenarios. Okay, this is a real world scenario that comes while testing real world applications. So manual testing deep dive. What is manual testing? Manual testing is a hands-on process where human testers interact directly with software to evaluate its functionality, usability, and overall quality. Okay, testers execute test cases without automation tools, without using any tool, simulating real user behavior to uncover defects. This means that human testers interact directly with the software in manual testing. And what is the core objective of manual testing? To verify software performs its intended functions correctly, what was provided by the client, identify bugs, errors, and inconsistencies in behavior, ensure the application meets documented requirements, assess user experience and interface design, validate compatibility across different environments. Manual testing remains essential for exploratory testing, usability testing, scenarios requiring human judgment and creativity. Okay, so what are the best benefits that only manual testing can provide? Any guesses? Not the automation testing. Yes, user level testing we can perform. Anyone else? Only one person is answering. Why others should also interact? Anyone else? Okay. So the answer is exploratory testing. So exploratory testing cannot be performed using uh, automation testing. Exploratory testing is done by human brain. Okay. So a human brain is not just equivalent to the softwares. Okay, so a human brain can exactly point out some things in real time while testing, the things that are not covered in the test cases or use cases. While testing also, exploratory testing can be done based on the gut feeling, like uh, Comprehensive testing levels. So, software testing encompasses multiple levels and types, each serving a specific purpose in the quality assurance process. Understanding these different testing approaches help teams build, reboost reliable applications. Okay. So first type of testing is smoke testing. So what is smoke testing? Smoke testing is quick verification that basic functionality works. Okay. The key functionality. It only focuses on the key functionality. Sanity testing. Sanity testing is detailed validation of specific functionality. It focuses on more of the detail. Installation testing. Installation testing basically verifies software installs correctly. So this is done for applications that need installation. Black box testing. Black box testing is testing without the knowledge of internal code. So black box testers actually test the application just like users. They do not know what is going behind in the code. They don't have any knowledge of the code. White box testing. White box testing is done with full code visibility and access. So box testers know the code exactly. UAT testing. UAT testing is user acceptance testing. It's end user validation before production release. Regression testing basically ensures existing features that work or not after the changes. Any change that have been done can also affect the existing code, and to ensure that this is not there are no bugs after changes, we do regression testing. Performance testing. So performance testing includes evaluating speed, scalability and stability of the application. Usability testing. Usability testing helps in assessing user experience and ease of use. So basically, how easy the application is to use, how intuitive is it? Like, is the user able to use the application without any support? Is the application intuitive or not? Smoke testing versus sanity testing. So these are main types of testing: smoke testing and sanity testing that we require to do again and again. Smoke testing is basically the purpose of smoke testing is to confirm basic functionality of the product, that works correctly and that the build is stable enough for further testing to proceed. So this is the very first step and first testing that we perform on any of the release. So smoke testing is done. What does it do? It only targets the key functionality. It validates fundamental features and critical paths performed immediately after receiving a new build. It acts as a gatekeeper for testing process. Okay. It's for its quick execution and broad coverage. Since it focuses on the main part, so it covers the main part. Think of it as a general health checkup for a software. So what does general health checkup include? When we go for a general checkup, it includes the basic and the key functionality in our own body, that it's working correct or not, right? Then if we find any bug there, then we if we find any issue in health, then we dig deeper and go for the specific tests. Similarly, if we find any issue, then we go and dig deeper for the specific areas. Sanity testing. The purpose of sanity testing is that it provides detailed testing for specific functionality, okay, to ensure that the software runs without logical errors after bug fixes or minor changes. So sanity testing is done directly after uh, some fixes or minor changes have been done in the existing software, and it's done for the specific functionality to ensure that there are no errors that have been generated due to the changes that have been done. The key points are deep dive into specific areas of functionality performed after smoke testing passes. Okay, validates that the bug fixes work correctly. Narrow but thorough coverage. Think of it as a specialized health checkup, the specific health checkups that we do. Okay, there's a quick question that you can think in your mind, that you received a new build at 5 p.m. on Friday. Okay, smoke testing fails immediately. The login page won't load, right? So, this is the basic functionality that the login page is not loading. What should you do? Any guesses? Yes, we should inform the team, because it's very crucial bug. And if the if login pages are not only loading, what will you test further, right? So you should stop and report the issue. That is why smoke testing is the first step and sanity testing is done later. Smoke testing essentials. Smoke testing serves as first line of defense in quality assurance, acting as a build verification checkpoint that determines whether the software is stable enough to undergo more rigorous testing. Okay, build stability verification. So, smoke testing confirms the basic functionality works and verifies the build is stable. It checks for critical issues like code cracks, major leakages that would prevent further testing. Okay, it's performed on every new build. Smoke testing is executed every time a new build is released. Okay, ensuring consistent quality gates through development cycle. Right. What are prerequisites for sanity testing? This testing is performed before sanity testing to ensure the application is ready for more detailed examination. Right. It saves catching showstopper bugs early. Also known as build verification testing. The industry commonly refers smoke testing as build verification testing or BVT. It emphasizes on its role in validating build integrity before deeper testing begins. Okay, sanity testing essentials. So, sanity testing provides focused, detailed verification of specific functionalities, ensuring that recent changes, bug fixes, or minor enhancements haven't introduced any new problems or broken existing features. Okay, so it basically focus on the specific functionalities and whether the recent changes that have been done or the bug fixes that were reported do not introduce new problems or broken existing features. Okay, detailed functional validation. Sanity testing performs through examination of each functionality to ensure that the product runs without logical errors, going deeper than smoke testing. So, smoke testing was done only for the surface level, whereas sanity testing is done on the deeper level. Post smoke testing activity. This testing is performed after smoke testing passes. Okay, triggering by code changes or bug fixes. So sanity testing occurs after bug fixes and code modifications to ensure that the changes work correctly and haven't negatively impacted the related functionality. Okay, it validates expected behavior. So what was expected, expected output is equals to the actual output. The core concept is to check that the build is working smoothly as expected with new changes. Okay, confirming that it fixes actually and resolve reported issues without creating new ones. that the existing issues that were reported have also been fixed, and new ones are also not created. Sanity versus smoke testing in detail. Okay, so I'll read main points, like detailed testing of each functionality to ensure that the product runs without any logical errors. Whereas smoke testing, what does it do? It confirms the basic functionality. Okay. Sanity testing is performed by testers who understand the functional requirements, whereas smoke testing is performed by developers or testers immediately after the build creation. So not only testers but developers also perform the smoke testing after creating a build, just to ensure that at least the basic functionality works. Objective is of sanity testing is to verify the functionality. Okay. And once it's verified, then we proceed to rigorous testing, whereas smoke testing verify the stability to proceed with rigorous testing. Sanity testing is just like a specialized health checkup, whereas smoke testing is like a general health checkup. Sanity testing focuses on it has a narrow scope and deep coverage of specific features. Okay, whereas smoke testing focuses on it focuses on a broader scope and shallow coverage of critical paths. Sanity testing takes longer to execute and is detailed due to the detailed nature, whereas smoke testing is quick to execute and it provides rapid feedback. Okay, since it's on crucial stages, so it requires quick execution. So there's a real world scenario that your team has just fixed a critical bug in the payment module. Okay, so payment module is a very critical part, and team just fixed a critical bug. You have limited time before release. Would you perform smoke testing or sanity testing first? What would help each approach to help you verify it? So the answer is we will perform. Yeah, anyone? Yeah, sanity testing. Not the sanity testing. For we have limited time before the release, right? So what do we perform for limited release, limited time? Yeah, first of all, we'll perform smoke. We will not encompass the stages. So, first of all, smoke testing will always be performed. Then only we move to sanity testing if we have time, right? First of all, the critical part has to be tested first, always, right? So, this is the first step. Sanity testing is always the second step. Software project environments. So there are basically different environments in a software project. Okay, these in professional software development uses multiple isolated environments to ensure code quality. Okay, not only code quality but also minimize risk, enable smooth deployments. Okay, in SDLC process we have different environments that help us to get smooth releases. First is development environment, also called as dev. In environment, developers write the code, they test and debug the code. So this is in completely different environment that from what the end users actually see. Okay, this is an isolated workspace for active coding and unit testing. Okay, often running on local machines or shared development servers, from where code is deployed again later on. QA or the testing environment. So QA or the testing environment is basically where the testers work. Okay, it's a dedicated space for QA team to perform comprehensive testing. Okay, this environment mirrors production settings and host various testing levels, including functional, integration, and regression testing. So all these types of testing is done on QA or testing environment. So then comes the staging or UAT environment. Okay, staging or UAT environment is pre-production environment where end users and stakeholders perform user acceptance testing. Okay, it is almost the same version that will be deployed to the production, that is the uh, main environment where end users work. So it's nearly identical to the production, allowing final validation before release. If there is any issue comes in staging environment, then again it goes to developers, then again it comes to QA, and then for staging. If the staging environment passes, then it moves to production environment. So what is production environment? It is the live environment, the live where apps work, right? Where the end users access the software. This is real world deployment where all previous testing culminates in a stable and functional application. So in this environment, in production environment, there are no issues. After all the tests have been passed, then only we release our app to production environment. Any questions till here? Yes. The previous slide. Third point. You mean to say from the on the third slide from the starting? Okay, first of all, I'll tell you about the production environment that you asked. So basically, production environment is the live environment. By live environment, we see that the environment that end users see. Who are the end users? So end users are actual users of that product. Okay, so for example, take any app like Instagram, Facebook. So all the users that are using it are the end users. Production environment is the actual environment where it's real users use it. Okay, development environment is the coders environment. QA environment is the testers environment. Staging or UAT is the stakeholders or testers environment again, right? Whereas production environment is the actual end users environment, right? All the code, whenever all the code is deployed, it's deployed on production. Okay, any doubt? Because I didn't get confidence in on your okay. Mhm. Product based and service based QA role. So what is product based according to you? I'll tell you. So basically, what is a product software? Product software, as from the definition, what do you get? What is a product software? It basically is for the segment of specific segment of customers or a broad market audience, right? Just like the examples that you quoted, right? Uh, Even Facebook is a product software. because so many it's a larger segment that is using that product. It is not created according to the specific needs of a particular person or a particular company or team. Okay, it is based on generic requirement. And what is project software according to you? Yes, it's based on the specific requirement, okay, of particular clients. So the examples are banking systems. So the banking system software, layman and the normal people cannot use it, right? Yeah. Similarly, ERP, the enterprise resource planning, and CRM systems that you know take care of and maintain all the records. So those systems are not accessible to the normal people outside that company. So they are basically adhering to the needs of that particular client based on those requirements. So that is a project software. Okay. Any doubt? Anyone else? Yeah, please. So basically, these both are different, topics. We perform both basically. So manual testing and automation testing, both are performed. It is not specific that only manual will be performed or automation will be performed. Yes. So UAT testing is acceptance testing, and it will be done after the it's passed from QA. So if QA has passed, okay, then it's deployed to staging or the UAT environment. So then the stakeholders are asked to just the uh, review that particular release, okay, on the UAT environment. And it's basically to get an approval from the stakeholders as well. It is exactly same as what will be deployed on production, but before deploying it on production, we ask users to give real feedbacks. Yeah. Is the answer satisfactory, or you need more details on it? So UAT will be directly done by the user. Users will directly we will provide the access to the users, specific users, those that are shareholders, the stakeholders, or the clients, and they will perform that user acceptance testing, and they will provide the direct feedback. There are no specific tools. It completely depends on company to company. Okay. Yeah. Any other questions? You can note down the questions if you face or find after the class, and we can discuss the rest of the questions tomorrow also. Okay. So